We previously talked about the concept of molar mass, the mass of a mole. Molar mass can be found on your periodic table. If you look here, there's like little periodic table tiles for hydrogen, sulfur, and oxygen. The smaller number in the box is the atomic number. That's the number of protons. The larger number in the box is the mass. But previously we called that the atomic mass or the weighted average mass, as it was a weighted average of all the different isotopes and their abundance in nature. Well, now we can use those masses to represent grams, but we have to think of them in a little different light. If I want to say that the mass of oxygen is 15.999 grams, I can't say that it's the mass of an atom. It's the mass of a mole of atoms. That's a lot of atoms, 6.02 times 10 to the 23rd, right? And so it is something that we're going to use a lot because we want to measure in the lab, and our balances measure in grams. So it's going to come in real handy to use our periodic table to find the mass of a mole in grams. And now that would be a number that I can realistically measure. I can measure 16 grams of something in the lab, or 32 grams, or 1 gram. Those are reasonable numbers to measure in the lab. Measuring one atom, that's not going to happen. Like, we can't even isolate one atom. It's crazy, 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 crazy tiny. So now we want to think about molar mass of a compound. All right, so I think sometimes there's a little confusion in like ratios and comparing the ratios of molecules and ratios of atoms and this whole thing with a mole. A mole is a unit that's hard to comprehend because it's a lot of particles. So what if we scaled this down and said that I had 12 water molecules? I have 12 water molecules. I have a dozen. I have 1 dozen water molecules. Well, now let's say the question said, how many total hydrogen atoms? And we'd say, okay, well, each water molecule has 2 hydrogen atoms. I have a total of 12 molecules. So 12 times 2, I can count that, right? There's 24 hydrogen atoms. But we could also write that as 2 dozen. I had 1 dozen water molecules. Then by looking at the ratio, every molecule has 2 hydrogen. So would it make sense then that I could say I have 2 dozen hydrogen atoms? I have 24. Kind of along the same lines, I could say 1, 2, 3, 4, 5, 6 times 2. There's 12 oxygen atoms. There's 12 water molecules. Each has 1 oxygen atom for a total of 12. But I could also write that as 1 dozen. And so if I start with a dozen water molecules, I can also kind of break it down and compare like an amount of hydrogen atom and an amount of oxygen atom. That's what a compound is, right? It's different elements that are joined together, and we're really concerned with the ratio of atoms for each element in a compound. So I think most people understand this, that if I had a molecule of H2SO4, it's 2 atoms of hydrogen, 1 atom of sulfur, and 4 atoms of oxygen. But then sometimes when you put that mole unit in there, people are kind of like, what's going on now? Well, let's just say that I had a mole of H2SO4 molecules like this. I mean, initially above I only had 1 molecule. Well, there's no way I could draw out this many, 6.02 times 10 to the 23rd molecules. I'm not drawing that. It's crazy. But if I did have a mole, that just is a quantity. And so we can still kind of look at the ratio of atoms for each element, kind of like how we thought about the term dozen. That if I had 1 mole of H2SO4 molecules, there'd be 2 moles of hydrogen atoms. Kind of like my water molecule. If I had 1 dozen water molecules and each molecule has 2 hydrogen, it breaks down to 2 dozen hydrogen atoms. And we can kind of do the same thing, but using the term mole. It just represents a couple more than 12. Now, if I wanted to know then exactly how many hydrogen atoms, I could multiply 2 times 6.02 times 10 to the 23rd. So I could say I'll say like 1.2-ish. 1.2 times 10 to the 24th. It's like 12 times 10 to the 23rd, but if I put that in proper scientific notation, that'd be like 1.2 times 10 to the 24th. That would be the number of hydrogen atoms. There'd be 1 mole of sulfur atoms, 6.02 times 10 to the 23rd. Awesome. And then 4 moles of oxygen atoms. So if I kind of estimate, 4 times 6 is 24. So like 24 times 10 to the 23rd, or 2.4 times 10 to the 24th. Oxygen atoms. So in a compound, we can look at the overall structure of the molecule, or we can break it down by each individual element. And then we can find the mass of the compound, the molar mass of the compound. And so they're showing this work down here, and it's fine. Eventually, I don't need to see all of this when you're doing the molar mass of a compound. I don't need to see it written out exactly like this. But let's just see if it makes sense. I had 2 moles of hydrogen. On the periodic table, each mole is about 1 gram. Then I have 1 mole of sulfur. The molar mass of sulfur is about 32 grams per mole. And 4 moles of oxygen, and the molar mass is about 16. So we multiply and add and get a total mass of about 98.1 grams per mole. And that then should be the H2SO4, a mole of H2SO4 molecules. So let's check out number 9. The table shows the total mass of carbon dioxide as a function of the number of moles of CO2. Complete the table. Okay, so this is going to be so easy. Check out what they've already filled in. 1 mole of CO2. So if I had a mole of CO2 molecules, would break down to form 1 mole of carbon atoms and 2 moles of oxygen atoms. I'm just looking at the ratio of atoms in the formula. Here's how they got 44. So to get the 44, here's all the work that I need to see. I just want to see you say, okay, carbon. There's 1 mole of carbon times its molar mass. It's about 12.01 grams per mole. There's 1 mole. Then oxygen. There's 2 moles, and the molar mass is about 15.999 grams per mole. And then add them up. That's what I need to see for work. You don't have to show molar mass like what they did down here as a bunch of little proportions. I'm okay if you just want to add it up. But then when it says show work, just show me what you plugged in your calculator. Well, I had 1 mole of carbon times the 12.01 off the periodic table plus 2 moles of oxygen times the mass of oxygen. So you'd add these together then, and that's where they're getting the 44.0 grams per mole as the molar mass of CO2. That is totally fine for showing work. Show me what you're plugging in your calculator. Now, do you kind of see what they're doing here? Like, what if I had 2 moles? Well, if I had 2 moles of CO2, and each mole of carbon dioxide has 1 mole of carbon, could I then say that there would be 2 moles of carbon? There would be 4 moles of oxygen atoms. And now watch what you can do for a calculation. You could say I have 2 moles of CO2. And now if you want, you could set up a little proportion to say, well, every 1 mole is, let's put grams on the top, 44.0 grams. so that the unit I want to cancel goes on the bottom, and I want to switch it to total mass. I want to switch it to grams. That goes up on the top. Oh, well, if every 1 mole of carbon dioxide is 44 grams, then hello, 2 moles is 88 grams. That's all they're getting after here. I can then just change this number out in front and say, now what if I had 3 moles of CO2? Well, then there would be 3 moles of carbon. There'd be 3 times 2. There'd be 6 moles of oxygen atoms. And then I would just multiply. 3 times 44 would be 132. And you could say 0.0, I suppose. 132 grams. And then I can do the same thing, switching this to a 4. Oh. I think this mole concept is one of those things where you just have to practice it a little bit, and then all of a sudden it'll click. I promise, it'll come to you. If I had 4 moles of CO2, there would be 4 moles of carbon atoms, and there'd be a total of 8 moles of oxygen atoms. It's like saying molecules, but just multiplied by a lot. Like if I had 4 molecules of CO2, each molecule has 1 atom of carbon. I'd have a total of 4 carbon atoms. It's just that now when we say moles, we mean that we have a large quantity of carbon dioxide molecules. But each one still has 1 carbon and 2 oxygen. And each mole still has, whoopsies, there we go. Each mole still has a mass of 44 grams. So if I had 4 moles times 44 grams, 176 would be my total mass.